Hello, my name is Brentton White, and this is my project for DES105, Game Engines and the Principles of Programming. My project is a 2D side-scroller with a flying character who has the ability to shoot. We'll begin with the Start menu screen. Both this screen and the Game Over screen are effectively identical in design, and as such, what's true for one can be assumed to be true for the other. In the main game screen object, you'll note the basic UI necessities, such as a canvas object and the graphic raycaster. There are multiple additional elements that I won't discuss, as they were constructed via a step-by-step Unity tutorial and required very little of my own innovation. However, you will note as we look at the game screen object that there are several scripts of my own in here. Using the inbuilt on-click function for the menu buttons, the Start button calls on the Scene Management function, which, as this code will show, instantiates a string variable and then calls on the value of that string to load a scene. In this case, the exact name is Primary Scene, the name I gave to the scene that holds the main portion of my game. The Exit button functions nearly identically, with one key difference. It uses a basic inbuilt application.quit method to terminate the game session. Now, we will enter the game itself. One of the first things you will notice as my character moves around is that the camera travels with the character. This is as a result of using Unity's inbuilt 2D camera. I briefly considered trying to create my own before I found Unity's inbuilt 2D follow script. As a result, the camera tightly follows the player through the game. Speaking of moving, the method by which the character moves is relatively simple. As we'll see when we look at the player controller script, a sort of catch-all script I made for anything and everything involving the main player object, its update function contains a series of if statements that check for the depression of the arrow keys. For every frame that these keys are pressed, the location coordinates of the player object, known as the object's transformation position, is updated in the following algorithm. Vector 3 is multiplied by a float called speed, which is then multiplied by the time delta time, the amount of time it took to complete the last frame. This moves the player accordingly. Note that when the player presses left or right, the character sprite flips. This is achieved using a bool that is flipped back and forth depending on player direction, and a quaternion modification. What is a quaternion, you ask? That's a good question. Even Unity says in their own manual that they're difficult to understand on an intuitive level. But as far as us designers are concerned, however, it's the keyword needed to flip the sprite via code on its y-axis. Speaking of sprites, you will note that there is a basic animation at work on the player object. While I had initially planned to go more in depth with my animations, unforeseen problems required me to leave this as basic a concept as possible. Ultimately, of the 4 animations in this game, all of them were created just by dragging and dropping a set of sprites onto the editor and letting Unity do the rest. I'll now discuss my last minor feature, the end game concept. In this particular case, much of my game runs on the concept of collisions between objects of varying tags. As can be seen here in the player controller script, if the object the script is attached to encounters a collision, it then checks the tag of the object it collided with. If the tag matches one of 4 different tags, an additional action is taken. The tags enemy body, enemy projectile, and death hazard all start a function called player hit, a function I will discuss about when I talk about the player death concept. However, the win object tag triggers a different series of events. It destroys the object that was touched, flips a bool called player not winning, and then starts what's called a coroutine. A coroutine is a process for methods to be temporarily suspended to allow additional functions to take place. As far as this project is concerned, they're an easy way to do timed events, which, in the case of my game, comes in the form of both the victory and death features. Using the keyword IEnumerator, an additional function of the same name as the coroutine is activated. It uses a yield return and then instantiates a new wait for seconds method. The yield keyword is the process by which the enumerator pauses itself, and the return is required to be fed into the enumerator that runs the coroutine. This coroutine in particular pauses itself for 4.2 seconds, long enough for the sound clip to play, and then loads a scene of a specific string name, in this case, end screen. Moving on to the player attack script, you'll note the use of get key down as opposed to the movement's get key in order to limit the number of bullets the player fires. Once triggered, the code uses an instantiate method to create a previously determined object, seen above as public game object projectile prefab, with the set position of the object that holds the script, in this case an invisible child object of the player. Once done, it applies a force to the rigid body of the bullet object. Even more than this, it fully recognizes the y-axis rotational shift of the player, and will fire off to the left if the player's sprite is flipped. I had originally intended to add a limitation to the number of bullets the player could use, as seen with the instantiation of a list, but ultimately ran out of time to produce the necessary code. The enemies that shoot run on a very similar script to the player. However, it relies on a collision with a player tag into a specific trigger zone attached to the enemy object. I also used a trigger stay instead of trigger enter, giving it the ability to activate multiple times without the player exiting the trigger area. The bullets themselves have a few scripts of their own. The first of these is a simple self-destruction script, as well as the creation of an explosion animation when it collides with other objects. The timed destruction script was my first attempt to code a death sequence, but the coroutine process ended up proving easier to implement. In this method, I tell it to activate a specific method by name using the invoke command, and additionally tell it to do so in a specified time frame. As for the explosion effects, the animation was a simple drag and drop, but what is special about this code is the way in which the explosion was instantiated. One of the problems I ran into in its creation was that it would be destroyed with the parent bullet before it visually registered on a screen. A solution to this that I found was incredibly simple. Transform.detachChildren. It detaches the child explosion object right before it destroys itself, creating the illusion that the bullet explodes on contact. You may have noticed in my explanations several instances of the code calling on various components from the player object. This is related to a pause feature I created. In every object which moves, has any action or any animation, the script constantly checks the status of two bools in the player object, player dying and unpaused. Right below these are a series of if statements, as I learned that modifying the timescale in only one script would affect only the objects possessing that script. The flipping of these bools is all handled in the player controller. As can be seen here, whenever the player presses tab, it triggers the bool unpaused to switch, which not only triggers a timescale change in the central controller, but will also trigger identical changes in all other scripts. As for player is dying, that's even simpler. As was seen before, whenever the player collides with certain tags, it triggers a simple method called player hit. This method then activates the coroutine for death as long as the player hasn't already collected the previously mentioned victory object. The coroutine itself is simple. It triggers a timescale shift, similar to the other ones seen before, and then flips the player as dying bool. Then it triggers a similar weighting effect to the victory coroutine, adjusted downward to account for the smaller timescale. Its last effect is to reset everything and then restart the scene. My last complicated function is the process by which moving non-player objects work. This was a pain to figure out. It starts by instantiating a list and allows the editor to add waypoints to this list. The trigger is activated every time the wait time variable is equal to the elapsed time since the start of the frame. Once the movement method is activated, a vector3 move towards function is used to move the assigned object to the designated waypoint object at the designated speed. When it reaches the waypoint, it increments the waypoint index and starts the process again. When it reaches the last waypoint, it recycles the list and starts over. The last little bit of this script applies only to objects tagged as enemy body. This portion will flip their sprite in a manner similar to the way the player sprite flips whenever it hits a waypoint. The key flaw in this method, however, is that enemies must be on waypoint paths that have an even number of waypoints. Otherwise, they will periodically switch between walking backwards and forwards. There's only 3 minor things left to cover. Each of these was added in the latest stages of development and are very simple in nature. The first of these is a magnet obstacle. On the player is a basic script that states that whenever the object carrying this script collides with an object tagged as magnet, this object becomes a child of the magnet object. Additionally, whenever the collision ends, so too does the parent-child relationship. The second of these is a very basic version of parallax scrolling, using a second camera. By creating a child camera, thus forcing it to move automatically with the main camera, and telling this camera to only display the background sorting layer, a scrolling parallax effect is created in 2D. To better sell the illusion, the camera size is changed significantly from the main camera, giving the impression that the background is much bigger than it actually is. The final concept was the basic implementation of sound effects. Each of these functions in a similar way. By telling the script to load the respective sound effects to a sound source attached to the relevant object, the audio source play sound method becomes available, playing the loaded sound effect whenever the specific method is fired. Thank you for your time. My name is Brentton, and I hope you enjoyed watching my presentation.